name is Ruthvik. Is my actual name. I currently work at Amazon. I'm just practicing system design, uh, partially for fun and just preparing myself for future. I've worked for 2.5 years there. Worked a lot on operating systems. We built our own custom operating system with enterprise management. Um, and currently I work on AI powered assistants. And yeah, that's a bit of what I do. Yeah, that's it for
Awesome.
me.
It's good to hear from you. Just a quick little housekeeping kind of thing. These interviews are usually 1 hour long in the real world. There's going to be some introductions, some questions. We won't be doing that for the most part. The technical part will usually be about 45 to 50 minutes, and so we'll target the kind of that range. So that's for your housekeeping as well, just to note, for your own time control. And at the end, we'll usually leave about 5 to 10 minutes for any feedback, and of course, questions that you have about the process or how you did and whatnot. So if there's no concerns, we'll just get right into it.
Yep, sounds good.
Great. Okay. So for today's problem, we're going to be designing the Twitter timeline. Okay, so the Twitter timeline, we'll have a couple use cases here. By the way, you're free to take notes just straight into like ScalaDraw, like whatever is convenient for you. So what the Twitter timeline means in this case is that we want to be able to we want to design a system in which users can post tweets, and users can pull tweets. Can read their timeline, right? And so there's interaction in the sense that users follow other users, right? And if a user follows another user and their followee was posting a tweet, that tweet should show up on their timeline. So that's kind of the product requirement for now, and I want to just see how we kind of approach that. Oh, did you? Are you still there?
Oh, sorry, I was pushed to talk. Um, just to make sure I got everything that you kind of briefly said. Users can post tweets, pull tweets, so like just get more tweets on their feed, follow other users, and users they follow should show up on their feed. Okay. Is that the
Yep, that's
rough
right.
of what you said?
Yep,
Okay.
that's exactly what I said.
Um, so in terms of uh, how many users will like be using this every day, um, whether this is highly available or consistent, let's start with that and go from there.
Yeah, sure. So I think the main thing here we were going to be talking about is availability. Consistency, of course, we want eventually consistent. That's kind of the standard, the benchmark. But for now, the only non-functional requirement you can call it would be availability.
How many users are we expecting to be
Oh,
using
sorry, I
this?
missed that part. So we'll have about. So I'd say we'll start with 10 million users, and we'll say that on average these guys post 5 tweets a day. So that's going to be 50 million tweets per day.
50 million?
50 million tweets per
Okay.
day. Yeah, and you're free to
Okay.
ask about any other questions. I'm not. I'm just answering what you're asking.
Did you say 10 million users?
Yeah, 10 million users, and each user will
Okay.
post on average 5 a day, 5 tweets a day.
Okay.
Yes.
Okay. Okay. Are we expecting, I mean, this might be us, are we expecting any users that are more followed than others?
Yes, we are.
May have.
Yes, we
Okay.
are. So there will be
Uh,
some users which are celebrities you consider, right? Some celebrities.
okay. I can't spell, but yeah. Okay. Just to keep in mind. Mm, post tweet. Okay. So, I guess I'll dig into it further. But should I start modeling some of the data or just like the API shapes?
If you feel like you're comfortable with modeling, we can go with that immediately. If you have other questions, you can always come back to that. That's fine too.
Mhm. I guess I will come back to that as I dive a little deeper. Um, maybe, let's see. Celebrities. Oh, in terms of whether this is a global thing or not? Is it regionalized? Are tweets expected to be globally available?
Yes, tweets are
Um,
expected to be globally available.
okay, global. Okay. Uh, okay. So let's get into some of the shapes. Uh, so there will be some form of get. Tweets. And this will be some form of post. Um, request that someone will make, a user. There will also be users. Um, we don't care about the whole user life cycle, like creation and all that. Just
No,
the
we don't
tweet
care
part,
about
right?
that. Yeah, we can assume that that's
Okay.
already handled. We're just
Okay.
talking about the timeline essentially. So posting tweets and reading tweets.
Okay. So this will be user ID that will be referenced with the tweet and the tweet like content. So that's like some of the rough parts of that. Um, let's see, you can follow some user. So then there will be hmm, some user ID that you want to follow associated with. Uh, hmm, let's see. Um, so user ID for the person that wants to follow someone and the user that follow it. I don't know what to call it, but someone that they follow. Uh, I don't know what the right word for that, but I'll just go with that for now.
User ID, follow ID. Sure, you can say a follower, followee. That works too. But it's up to you. It doesn't really matter.
Oh, oh yeah, okay. I'll just keep it that way for
That's fine. Yeah.
now. Another one is let's see. You have follow other users. Users they follow should show up on their feed. So some kind of get request. Um, and it will just take the user ID that wants to see tweets, and then the backend will handle what kind of content they'll see. Um, let's see, anything else? Pull tweets, all other tweets. Yeah, I guess that those shapes for now will handle that roughly. Um,
One question I wanted to quickly ask
mhm,
is in
yeah.
in your post API for tweets, what
Mhm.
is content supposed to be?
Oh, right. So content is some like form of string.
Okay.
Uh, Good question. So on that one, how big do we want this tweet like content to be?
Yeah.
Um,
Uh, so some content is going to be text,
mhm.
right? And then some
Okay.
content is going to be like media, right? So
Okay. Yeah.
yeah, you can have media there too. Yeah.
Okay. So that's good to know. Text, media forms of image or videos.
Sure. Yeah, that's
Uh,
fine. Yeah.
okay. Let's see. Um, so I'll just call them attachments and and for the media part, and then the string, the content is just like whatever they say. Do we have any restrictions on how long that content can be?
Yeah. So we can do the classic Twitter. I think it's like 140 characters.
Okay. Any restrictions on images or number of images or videos?
Let's just say the sum
Or
of attachments can be a maximum 1 megabyte. Yeah.
okay, sounds good. Um, all right. First I'm gonna start with just the getting the tweet and uh, posting a tweet in just a rough overview, and then we can get into following each other, um, and getting that information as well.
Okay, sounds good.
Um, so let's just start with there will be some form of client that users will interact with. Question. I don't know if we want to get into this kind of discussion, but do we need to consider, do we just want to focus on the development or anything in terms of like how many people are working on this or the deployments or any of that kind of
No,
stuff?
don't need to worry about deployment or DevOps. Just need to worry about the system design for this
Okay.
one. Yeah.
All right. Sounds good. All right. Hmm. So for now, I'm not going to add any extra layers. We're just going to focus directly to services, and then I'll add additional layers as we kind of tackle some of the other non-functional requirements.
Sure.
So let's say there is mm, tweet service, and we're going to make calls to the tweet service. We did say that uh, there will be image or video attachments, so that will require some form of storage that will handle that. So I will just pick some sort of blob storage to store the images or videos, like a file store. I'll go with S3 in this case. This is highly available in terms of, I guess, AWS v9s and globally distributed. So I think
Okay.
that will be good for now. Um, it does have, in terms of security speak, it does have at-rest encryption. So if we do care about keeping that safe, though most of it is all public, so it's not a big uh, privacy issue. So that's not much to consider there, unless if we want to consider it.
No, we don't need to worry about
Uh,
security or authentication in this case.
okay, sounds good. In terms of the database, let's see. Are we doing any transactions? No, we're just going for availability. Consistency is okay. So I'm leaning towards a more of a NoSQL database, whether that's MongoDB, Dynamo, I doesn't really matter. Or
Can you quickly explain the reasoning on that one? Why are we going with that instead of, for example, a relational one?
um, let's see. So mm, if we go for a NoSQL distributed database, it'll be available um, around the world. If we could go with an SQL database, it's just we would have to have more of a actually in terms of doing queries for, let's say, if I'm following someone and I want to get all their uh, every single person I follow, get all their posts, doing queries like that are easier on an SQL database. So in that aspect, it does make sense. In terms of how many writes we're doing, let's see, we're doing 5 tweets a day. There's 10 million daily active users, so 50 million tweets. That could be handled with um, certain like write databases that like replicas that we act as the master to write to. It seems like most of this activity will be reading a lot of tweets. So I'm guessing it's more read heavy than write heavy. Is that right?
Yes, that's right.
Okay. Oh, 5 tweets a day. Sorry. Words are just so. Let me think about that. Actually, it might make more sense to have, in terms of querying speed, types of things we query. It also depends on how we model the following. Um, whether that's a graph-like database but I don't think we really need that if we don't care about getting into like, second or third connection. Uh, Actually, uh, we could go with the SQL database. We would just have to consider having, for example, in different regions, we could have a database that handles more of the writes and then replicates that over to other regions.
Mm-hmm.
Since we do care about availability, it's okay. The consistency will be eventual.
Okay. Yep.
Uh, that way we could have, um, yeah, specialized replicas and focus more on the reading and leverage that. That will help us with querying uh, uh, faster in one query. So yeah, we could go with the SQL. So I'll just put this.
Sure. You can go either way as long as you can explain if that's
Yeah.
adequate.
I just go with Postgres for now. I don't really have a preference between Postgres or MySQL on that level, so I'll just go with this one. Um, this here, and just for now, I'll just say right, and then get right to that one, and then this one can replicate it over. So this, mm,
So let me clarify really quickly. This tweet
mhm,
service, what is
mhm.
it? What is it using this SQL server for? Like, what's this path supposed to? Is this the read or write path we're talking about right now, for example?
Sorry, this is right. So the tweet source is writing to the table, and the
what
read
is it
ser
writing to the table?
Oh, right. So for example, the post request.
Okay.
So people are posting to the tweet service. It's writing to the table. So this path, actually, let me just give a more description here. I write path, and then maybe another one could be a green, which we could be say read. I just added above. I will change that after. So just to kind of show
Okay.
the read path. Uh, Someone requests tweets. Right now we have the tweet service. It will go and read one of the read replicas that are available in that region. Um, and in case of how many writes we have, let's say we have one write replica in a region, one of the read ones could become a write in that region as a failover or to a different region. But
Mm-hmm.
so we could handle that. There will be a line to also read from S3. And let's see. So that's tweets.
And can we just
Follow.
quickly, and one thing before I'm going to move on there is in this SQL server, can you tell me? So, presumably, you have a way to store tweets in here, obviously. Can you
Yeah.
tell me what the key is and the fields that you'll have on this table?
Yeah, for sure. Let's go into that. So, uh, so let's say for posting. So let's just start with that. So we have a tweets table.
Mm-hmm.
We'll have a, let's see, primary key would be user ID, so the person who owns that tweet. Then we will have the content. Um, that'll be 146, 140 characters. And then we will have, since we have attachments, um, an SQL database, especially Postgres, mm, since attachments can be more than one, this will have to be a different kind of column type. I know in Postgres they allow like a JSON column. I mean, like a column. We don't
I believe
really
so.
need
Yeah.
to. We don't really need to query by attachments. As for a user's use case, it might be more analytic, but that could be processed a different way. So I think in terms of querying for the normal user use case, I think it's fine of having attachments, which is like a JSON list. Um, and we can kind of describe that a bit more. So it could be an array of S3 URLs. So just point at where to get this from. Now,
Okay.
whether do we need to actually read from S3? Actually, we won't need to read from S3 from the tweet service. So that won't need to be fixed. Once we return the post and it has any attachments, and we've given the user, actually, let me see, can the user, can we return it right in the request? Uh, yeah, we can. Or we can let the user read from S3 with a pre-signed URL, something like that. There could be a for essentially for tweets that kind of blow up. We may need, especially for the attachments,
Hmm.
we may need something like a CDN just to help, um, like cache some of those static um, uh, entities or artifacts. So that might be helpful for regional like edge caching for those artifacts.
Okay.
So I'm thinking of putting that there. Um, let's see. Oh yeah, we were going on about this. Let's see. So that's the tweets table. There will be another table to address following. So let's see. Uh, mm, primary key. What we generally want to do is, let's see. So someone has a lot of people that are followers. Uh, do we care about the view where like I'm a celebrity and I want to see everyone who follows me? Or do we more care about like I am following people and I just want to get those posts on my view?
I don't believe the first case you described is a valid use case. Your
Mm-hmm.
timeline will only be consisting of the tweets of the people who you follow, not the other way
Okay.
around.
Um, as in like when you go to your profile and you see like followers of you,
Yeah,
I don't think many people will be visiting that as much, so that
yeah,
doesn't need to be
that's
as
not
like
the spec. Yeah, we're only doing
okay.
tweets of the people you follow for
Okay,
your timeline.
so
Yes.
then in that case, primary key can be so I'm following a bunch of people, and there's gonna be a lot of them. Mm, So there's gonna be a primary key, which will be like my user ID, the person who I'm going to follow some other people. And then there will be the person I'm following. Um, so let me, before I do that, I'm just gonna model user. So user has some form of ID, which is a primary key. Uh, this can be some like string username. I won't get into the other attributes of that. Following could be essentially a many to many table, um, where it takes a user ID and it essentially relates to users uh, rows. So I'm just gonna say following ID of another user ID. That way, I could get for example, I'm a user and I query, give me all the user IDs, or like user ID of everyone I follow. This will help me get essentially that.
Okay.
Sorry for my naming. I just can't get that right.
Sure.
Um, that's what I'm imagining in here. So, for example, when I want to view all of the posts that I made from the people I follow, the client will go on the green path. The tweet service would follow the following table to figure out all the people that it has that you followed,
Okay.
and then from there it will get um, essentially all the recent posts. So I guess something I've or sorry, recent tweets. So something else to be considered is, let's say I'm following like maybe 1,000 people. I don't want all their posts coming in all at all the times, right? So I might only want of those 1,000 people who posted recently, and querying every single person into the tweets to figure out who's posted recently will be a lot of essentially uh, a lot of end queries. So let's see, how can we reduce that? Mm, so I'm following someone, and from there I get a bunch of tweets. Uh,
So this is the read path, right? Where we're trying to find the
yeah.
tweets to pull into the timeline.
Mm-hmm.
Um, One thing you'll notice is that in the current design,
Mm-hmm.
there is no way to avoid in reads because you have no let's say you have no index per se on a user's followers, like the user's followers tweets, that is.
Oh, I see what you mean. So you're saying, I see. So right now I can look at everyone I follow, but there's no way to correlate that directly to the tweets. I see. Uh,
Yes, and what that means is that if, for example, in your case, you want
mm-hmm,
to load the, let's say, 100 newest tweets between
mm-hmm,
for all the people you follow,
right.
you can't do that without pulling 100 or at least some number of tweets from everyone.
Yeah, then it would be like a very like, hey, I got this person I follow, get all their tweets, get all their tweets. Yeah, I see what you mean. Mm,
We also know that
mm-hmm,
the read path is more, it's a common, like more people will be reading than writing,
yeah,
right? Um, and so in this case, it might make more sense to do more work during a write than to do work during a read.
yeah. So, hmm. So some things we could do is, there's one thing you talked about is how do we make that as a query, um, essentially be able to query that faster without doing end queries. There's also the other part where it's like we could re uh, cache some things that we anticipate a lot of people will want to see.
Okay.
Um, so that was something I would wanted to get into later until it ran in. So let's say we added some sort of uh, cache, uh, whether it might be CD, Redis could be one of them that we could use as a cache.
Okay.
What this would be for is essentially anytime we're writing something, we could we could anticipate whether a user will be likely to like get a lot of requests for it. And initially, a dumb way would be anytime I get a post, we could put it into Redis. and
Okay.
that would mean like for every single user we would do that. Um, but for example, there may be users that never really need to be in Redis, so Redis is in RAM, so it's a more expensive form of storage.
Mm-hmm.
Um, and maybe it might not be a good idea to put every single user that writes to it temporarily in Redis. That may last like a day. But for example, someone like me who posts, I don't really need to be in Redis because I don't have any followers. But someone like Elon would probably want to be in Redis because he'll get a lot more people trying to read his posts.
Yeah.
So being a little smart on who we put into Redis would be a good idea to just first eliminate duplicate queries. Essentially, we could just dedupe the query into Redis. Um, so, for example, a user is getting, I don't know, a request. Let's see, how would we put it in and get it in Redis? So, a bunch of users want, they have all different people that they follow. Um, but Redis would store. Uh, Sorry, I'm just double thinking how that would be stored in Redis.
Okay.
Uh, because right now this is only concerned with following. I'm going to park that thought for a little bit, and I'm going to think about how we want to reduce the inquiries while I think about this in the back of my mind. Is that okay?
Yeah, sure. Just keep in mind
Okay.
that
Mm-hmm.
keep in mind that right now we can solve for the problem of just how I mean the Redis is a good idea, but
Mm-hmm.
it's still not clear exactly what you'll be storing in there. But like for
Yeah.
example, are you storing tweets, right? Okay, is it
Mm-hmm.
just a cache for your Postgres,
Mm-hmm.
which is what that would be, right?
Yeah.
Or are
That.
you actually storing some special relation in there that would reduce the
Yeah.
query? Because you would still perform the same number of queries if it was storing the same thing. It would just be faster.
Yeah. That's why I was like, okay, I kind of dug myself in a hole there
Yeah. Okay.
because it didn't seem like much of a relation. So I was like, let's solve the end relation. Maybe we might get a better idea for this later.
Okay.
So I'll park this for now. I'm actually just remove that for a sec. So let's say every single post I put, it will inherently have some form of like time it was created. Do we care about anything like how many people liked it as an indicator of like what's more popular? Um,
Sorry. What's the question? What's it solving for?
uh, do we want to care about anything like user likes a tweet?
No.
I actually forgot that. Okay, none of that or no comments,
No comments. Yeah.
right? Okay. So let's see. Uh, I'm a user that follows someone, and I want to get their most recent tweets of everyone I follow. Hmm, how do we bridge that? So there was something you talked about pre-processing.
One thing we should consider here
Mm-hmm.
is to have another table
Mm-hmm.
in our SQL database, which
Mm-hmm.
represents the timeline of a user.
A timeline is a set of posts that come in at certain times.
A timeline,
Oh, I
yeah, a
see.
timeline is a list of is an ordered list of posts. Yes.
I see. Okay. Oh, I see. Okay. Actually, that helps. Thank you. So with the timeline feedback that you provided me, that does kind of clear some things up because I wasn't thinking about timeline as an entity.
Mm-hmm.
So if having timeline as an entity, we can pre-process some things during write time. So let's say we see that, um, let's say we're getting a bunch of posts that are put into tweet service, and then we see we're gonna write that tweet into the Postgres. What we can also do is, I'm just gonna move things over a little bit.
Yeah. Sure.
Uh, what we can also do is put these tweets and the user ID into a service that will help us populate timelines. So this is like before someone even pulls a timeline. Um, what that would mean is, um, let's see. Before we get into that, I want to actually look into when we go into the timeline. Um,
Yeah, I
so
want I want to
timeline,
just clarify exactly the kind of fields in that table, right? The columns and also the key. I want to know the key of that table. So, yeah,
yeah,
I want to be explicit on that one first.
okay. So timeline would be like for the key would be user ID because we want to know from what is my timeline. Um, I don't think there is any secondary partition for this right now. It may be by the hour, maybe by the day, but I think there will be, for example, a new post gets added, so a tweet ID, and then we would either have the created time as the time it put it into the timeline or the time when the tweet was created. I think it makes more sense as a tweet creation time. Now, the reason for putting that in there is so then we can more easily query the more recent tweets. So if our front end is only like every time you refresh, it gets like the latest, like past hour or something,
Right.
uh, then we can query that easily. And by repopulating this, we don't have to query each tweet to get another n queries of time. So that's something we can do.
Just wanted to
Uh,
confirm that. So right now, is the timeline just going to be one tweet, or is it going to be? We said earlier a set of tweets. What's the difference there?
it will be a set of tweets. Uh,
Okay,
are you referring to how that would look differently in the database?
I'm just confirming because the timeline, you have
Mm-hmm.
like one tweet ID here. But previously you labeled a list as a list. So I'll just confirm whether this is a single tweet or if this is a list of tweets.
Oh, are you talking about like something like attachments
Yeah,
or
so
like
for
you're saying
example,
more?
for attachments, you're
Mm-hmm.
saying that the attachment of a tweet table is a list of items.
Mm-hmm.
Is the tweet ID here referring in the timeline? Is that referring to one tweet ID or a list of tweet IDs?
I was thinking a list of tweet
Okay,
IDs right now,
okay.
but maybe it, let's see, depends on how we want to process or how we want to chunk it.
A
Because
list
there's
is
some
a list
limitation.
is good.
Oh, a non-list is good? Or
Uh,
sorry, this.
yeah, list is fine. I just want to clarify because you didn't write the list specifically here.
Oh, I see. So are you saying a list is good here or
Yeah, so
not?
we can. So a timeline would be a table that
Mm-hmm.
consists of a user ID primary key. That's agreeable, and then it
Mm-hmm.
contains a list of tweets that we want to that consists of this user's timeline.
I see. I was thinking of them each as individual
Okay, that works too. Yeah, that
rows,
works. That works too. Yeah.
but that does work. And but in the sense like how we wanna, if we model it as separate rows, that's one thing. But we can also model those as buckets, if you will. It's
Okay.
just if we let's say the created time is like a little different. Like let's say for every 5 minute increments, it will store all the new 5 minute, like any tweet made in the past 5 minutes into this list if
Okay.
it were a list.
Sure. Yeah.
The only downside is like if I follow a like all like very active Twitter users that all post every 5 minutes, then this list would get really big.
Mm-hmm.
Um, so there's some limitations around it, but the advantage is that if we can carefully figure out, okay, what's the limit of that list, then we can reduce how much it has to query. So we could be like, instead of it being like every like millisecond
Mm-hmm.
uh difference of a row, this could be more buckets. And I think thinking about it that way, it would be a less intensive kind of query from the database because it has to go to less rows to figure out how many times. Um,
Yep.
so I'm thinking, which is uh, an idea from you. I think I'll steal that idea
Okay. Let's do that.
on the yeah. Anything else here? So I'm gonna make this like uh, time bucket. I don't know. We could make it every 30-minute time or 5-minute time, whatever uh, you're thinking.
Let's just keep it a high level, right? For the interest of time, I want to get through some more material here. So the time
Okay.
buckets, it's a fine idea. We can just move on from now.
Okay. Sounds good. So when a tweet comes in, what we can do is we want to process everyone that follows that person. So if a following ID has someone that's following them, then we want to process that. I think putting this into a separate, uh, it may not be as real time because it doesn't need to be. So I'm
Mm-hmm.
going to put it into some sort of queue, this form a request. Then we could have, depending on how many users we're going to process, um, we could uh, put multiple instances of a service. Um, I just drew two to indicate that.
That's
This
fine. Yeah.
could um, uh, timeline service. So we can have that. This can essentially read this queue, and it would update the timeline in this table. Whether we want to keep them as the same like database instance or not, I guess that could be a later conversation when that slows down too much. Because timeline could be a separate.
Mm-hmm.
Depends on how microservice you want to do, but I'll keep it like this for now.
Okay.
Um, so timeline service, essentially, it'll go through every one that they've. Let's say I'm a celebrity. I made a tweet. I have a bunch of people that follow me, so there needs to be a way to figure out how to get all of the followers. Right now, the primary key here is like the following direction, but I guess we also want to have the other direction. I guess in a secondary key, you can also query. No. Uh,
What's the problem trying to solve here?
so if I'm creating, let's say I'm Elon Musk, I put a tweet in, but I'm trying to populate everyone's timeline that follows Elon Musk. So it's the other way around for them. I'd want to see everyone who follows Elon Musk and get a list of those people and start updating their timeline. Um, right now,
Okay.
the following table works in the other direction where I'm a user and I follow someone,
Mm-hmm.
but not in the reverse. Um, so I was just thinking of maybe having a separate table to indicate the reverse. Uh,
So we're trying to find all of the user IDs with a specific following ID.
yes.
Is there an
I
issue with
wonder
the
if we
first table?
can it be queried in the second? Actually, you can query directly on the partition. I don't think it will just have to wait. How does that work?
I think it would be fine, no? Right?
Yeah,
Select
yeah.
all where
I think
following
it
ID
would be
equals
fine.
Elon Musk.
Yeah, yeah. It should be fine. Yeah. Sorry, I overthought that. Um, yeah, it would be fine. Uh, okay. I think that serves that point so far, the timeline aspect.
Okay. And then can you
In
quickly go
terms,
over the? So that was the write path for the timeline, right?
mhm.
Can we go over the read path for the timeline? Just walk me through that.
Yeah. So if someone reads, let's say they want to refresh their timeline, we would go to the tweet service. It would read the table. It would go for, it would put in that user's ID in the primary key, and it will give us a tweet list. So let's say the front end does the past hour or whatever they don't have on their local. Um, it will look up all the buckets and it will get all the tweet ID in the list. And for each of those tweet IDs, we would have to essentially do n more queries to get all this data. Um, now, this is this quickly gets us a list of things that we need on our timeline. Now, this is maybe where we can employ Redis now um, to help us essentially read more of the popular. Um,
Let's not worry about Redis at all. I don't really worry about performance for now. I just want to go through the full path so we can just make sure that
okay.
things are okay. So it's
Okay.
right so far that we would get the timeline. We would have a list of tweet IDs, right? Can you
Mhm.
walk me through what you would do with that now?
Once we have a list of tweet IDs, we would query or get all the tweets that we made
Mm-hmm.
from this table, which would get us a bunch of S3 URLs, and we return all of this information to the front end. The front end would get it, and then we would query any of the additional uh, attachments from the CDN, whatever's cached
Okay.
there, or not. If not, then the S3 buckets. So that would be the timeline read path. Um, yeah.
Okay. Yep, that sounds good. Um, I'm pretty happy with that. I want to ask one follow-up question here. We'll see how far we get, but time's a bit low,
Mm-hmm.
so I want to ask one follow-up question. Okay. So
Mm-hmm.
this wasn't part of the explicit spec earlier, but I did mention in brief that there are celebrities such as for example, the Elon Musk example you gave,
Mm-hmm.
right? And in this case, where let's say Elon Musk, tweets, right?
Mm-hmm.
What's something you can do to improve the performance in that case, right? Because right now, it is a case that you would have to write once, at least once. What in this case, once per follower of Elon Musk.
Sorry, I didn't understand the half part of the question. What about the rights for
Yeah.
each of
So
the?
yeah. So
Mm-hmm.
for anyone, so not just Elon Musk, but for anyone right now, right? If they tweet
Mm-hmm.
something, you would have to write once per follower, right to the timeline
Right.
table,
Mm-hmm.
right? For celebrities like Elon Musk, is there a way to be more efficient than that?
Mm-hmm. I
And we can
see.
keep it high level here. We don't need to draw anything necessarily. We just want to hear some ideas here.
Okay. So there are some people that would require updating a lot of people's timelines, and I guess that's one of the problems that come with this. How do we make that better for the celebrities? So a lot. Mm, First, I would need to. So what we could do is, for example, question is, what's the likelihood of someone following every single celebrity? This is a strange question, but
The
we could.
likelihood, we can say it's zero. No one
Okay,
follows all
so
celebrities.
so let's say, or this is the assumption of that someone who follows other people on Twitter will maybe have only a few people that are celebrities, and a lot of them are their friends.
Okay, yeah,
Um,
we can go with that.
on that on that assumption, I could say that updating the timeline is more effective for people who are not celebrities.
Hmm.
And for the people who are celebrities, let's say it's only a few, um, what we could do is just do the uh, n queries. Actually, let's see. If we do the n, we could store them, but no, that would essentially we would have if we maybe had a way of telling, yeah, hi, I'm following someone who is a celebrity, and get me all of those celebrities first, and mm, essentially just get each of their tweet IDs instead of populating all the timelines. That would mean I don't have to put as much data to as many people, but that means a lot of people would query.
It's a bit of both.
Yeah,
Um,
so
yeah.
I was thinking if we could have maybe another like is celebrity,
Okay.
if you will,
Sure.
and a way to indicate someone is more popular, then what we could do is figure out who's celebrity. For those people, they may not be in the timeline. For those people, we just figure out their latest posts.
Okay.
Um, and that could be something that's cached, and then it will be enquiries, but it'll be a limited amount of enquiries
Mm-hmm.
on the assumption they don't follow every celebrity. But if someone does, then that will be a bad experience for them.
Yeah.
And the timeline would be more of a non-celebrity or not as frequently queried people, which could be indexed by a different service that figures out who is more frequently, more likely, or needs to be cached versus who doesn't. Um, but yeah,
Okay.
I.
Yeah. That sounds reasonable to me. Okay. I'm happy
Mm,
to call the interview here, the mock here, and
yeah.
go over some feedback and questions that you may have
Mm-hmm.
about this question. I mean, first of all, I can just start with you. Like, how do you feel about this? Are there any parts that you feel like you did quite strong, or parts you did quite weak?
Um, so there was some parts I may have overthought something, and then I may have just confused myself. But I think I just tried to remember to keep asking you questions when I got stuck or used your feedback. So I think that part I did well on, like just
Okay.
thinking on what you said and not just dismissing it. Uh, Maybe not having too many thoughts at once, like just trying to focus on one, like the end queries versus cache, that kind of thing. I'd say is weak, but yeah.
Okay. Yeah, I think there were. I think that's a pretty good kind of intuition on the situation. Um,
Mm-hmm.
let's kind of start from the beginning of the process, and we'll kind of work our way forwards. Um, I think overall was the uh, the steps you took were right. Right, figure
Mm-hmm.
out the requirements, some numbers, right? Data diagram going, definition, whatever it is, right? You get the API shape, right? Some
Mm-hmm.
tables there as well, which are nice, and then working the diagram. So that's kind of like the right process. I like that process. Going down a bit more in each one though, I think it could have gone a little more deeply on at least the numbers, right? There were two numbers specifically that I omitted, which you need to solve this problem. And the
Mm,
first
I
number
see.
is the connectivity of the users, right? AKA, what is the distribution of users and their number of followers? And that's really important because in, for example, the last follow up, which is how do you handle the celebrity situation, right? A follow up to
Mm-hmm.
that question is okay, how many followers before you put them in the I think you call it a cache, right? Like how many followers before you put them in a cache, right? You
Mm-hmm.
can't answer that unless you know the connectivity of the users. So that is
Mm-hmm.
the kind of question which you gotta be aware of, right? All
Mm-hmm.
the network questions like this, like even at the beginning, you mentioned like this could be modeled as a graph database, and it could. You wouldn't be wrong to do that. But when you think of these kind of things, you got to think of the properties of the data, right? So this property is really critical to correctly model out some of the numbers. And I
Mm-hmm.
mentioned this
I see.
specifically here because in the lower levels of system design, the numbers don't actually mean anything, right? Like let's be honest, like I could have said 5 million, I could have said 500 million. That's literally a hundredfold difference, but I can guarantee you the architecture wouldn't change. Why? Right? Why is that? Because it doesn't really matter, right? But when you get into the higher levels of system design, the numbers start mattering, and some things would actually require you to think a little bit more about them, right? So, for example, at the beginning, we were talking about not the beginning. This is the beginning of the design. We're talking about should we use NoSQL or SQL, right?
Mm-hmm.
And that changes depending on how much write and how much read we have, right? What kind of sharding
Mm-hmm.
property do we have here? What kind of and you had this intuition, like what kind of indexes can we make on this kind of data, right?
Mm-hmm.
The numbers there matter a lot more, and so at this level, I would recommend you actually drill down and get all the numbers you need to solve the problem, because it's a
Mm-hmm.
bad because even if I don't ask the follow up, which requires the number, it's still a bad look for you if you don't have the numbers going into it, because then I know that you can't solve that problem, right? So just be aware of that. That even if you don't anticipate number being too important, just make sure you kind of go over things really quickly, because that doesn't take much time at all, just to type it out, right? So just get on the page. That's kind of the
Okay,
first
cool.
bit of feedback there. Um,
Mm-hmm.
right. So right, and another thing there is for so regarding the numbers, right, is if you like, for example, the tweet sizes, right? In this case, yeah, we know it's Twitter, it's 140 characters, right? But that's 140 characters is there's 0 bytes compared to the size of the attachment, right? And so if you
Mm-hmm.
don't get good information on the attachment situation, then you wouldn't then it'd be, again, you can't design that, right? For example, if the problem was that there are no attachments in their system, there's only tweets, then in that case there would be no S3, right?
Mm-hmm.
But you had already gotten to that stage where there's some assumptions that you made, right? Now in this case they're correct assumptions, right? We can have attachments and all that jazz, but um, right, like why not ask that ahead of time, right? So just clarify all the requirements, especially as you come across them.
Mm-hmm.
Get them down as soon as possible, because then it gives you as much time going forward, right? So that way you don't have to backpedal on a previous design and all that stuff. So it saves you a lot of time just to invest it up front and get the information.
Mm-hmm.
I had a note here, which is that so storing the S3 paths is great, right? Giving the user pre-send URLs is even better. That's a very good insight there. That's I can tell someone's worked with that kind of stuff before, right? There was last week I was working with a student who it was basically sharing files TLDR, right? And right, so it's more efficient to give someone a pre-send URL so that they can go use their bandwidth to download it instead of passing the file through your own system. So yeah, pre-send URLs are a very good touch. I would recommend you continuing to look for those kind of options whenever you can. Right, general rule of thumb is if you can save on your bandwidth, that's a good thing.
Mm-hmm.
Okay, this is another high level thing. Okay, no, before we get to high level things, I want to just quickly comment on the design process. But okay, before I go to design process, right? Okay, making the API shapes was fine. Again, the only feedback there is just to get all the data there as soon as possible.
Mm-hmm.
Table design is also fine, right? I think you missed the timeline structure,
Mm-hmm.
but that's not really a design issue. You just didn't think of that. But for what you did think of, that was also fine. The actual design, I think, went pretty smoothly. I agree that you took feedback really well, so that was really good of you to figure out when you're kind of stuck. Get a bit of feedback there. That was really good. I will say though, in that same vein, is that you should be a bit more explicit in the exact problem you're currently trying to solve, right? So
Mm-hmm.
sometimes you're telling us like, oh, I have a high level problem, work on the right path, work on this, work on figuring out how to use this table or whatnot, and then you kind of get in, and you're not very good at vocalizing what's going on. You kind of go into your own little thought. It's not mumbling, but I don't understand everything, and then
Mm-hmm.
you get kind of stuck. And then I have to go like, okay, like for example, this is with the following table, right? With the I forgot the exact reason, but you were saying you might need a different table for the other way around, right? To get a list of uh, followers for a given user,
Mm-hmm.
right? And it wasn't, and I could have stopped you earlier if I knew what you were trying to do, but I didn't really understand what you're exactly trying to solve. And then I saw you trying to make a new table. Then I realized, okay, that's definitely not right. So you could definitely help the interviewer out by giving more signals throughout your thought process, so they can stop you earlier if needed, right? Like
Mm-hmm.
it's strictly beneficial to you in that sense. Even if they don't stop you, you're still not worse off, right? So just keep that in mind. I think that's a practice thing. The more you speak about that kind of stuff, the more you iterate. Um, I think you'll get better at that. But just be aware that that was an issue in terms of time control, because you definitely had at least a couple minutes, like in that following example, and I'm pretty sure earlier as well. There was probably about 3 to 5 minutes of tangents, which you could have
Mm-hmm.
definitely saved on if you had communicated that more clearly. So just be aware of that. Um, and then one more thing about design side is you were really trying to pull out Redis a couple of times, right? And at the end there, I agreed Redis would have been the right solution for the celebrities. At the beginning though, right? Remember that Redis is not really like Redis only solves linearly scaling problems. Like it can improve your solution by a linear factor, right? Um,
Mm-hmm.
but it doesn't improve your solution by anything more than a linear factor. So it can't reduce your in writes down to like one write or five writes or something like that, right? So if it's a problem you're trying to solve with regards to writing tweets into people's tables, Redis wouldn't help you there, or Redis wouldn't help you there.
Mm-hmm.
And one more thing I will say about this problem, and this is common for a lot of problems, is that you should think about if you can, especially for something like come like Twitter or some other social media, like think about what it actually means to use that design, right? Like for example, um, a lot of the concern you have with getting a list of IDs but not wanting to pull them all, like read them all from the tweets table at the same time, you don't actually need to, right? Because a user will only be you might give them 1,000 most recent tweets, but they might only need to load 10 at a time, right? So it's actually a very paginated system. And in fact, right now, if you go to Twitter and you scroll really fast, it'll get locked up immediately, because even though Twitter knows the IDs of all the tweets in the last 1,000, it doesn't actually pull them until you request it, right? So be more explicit. And I don't know if you were explicit or you just weren't aware of this, but like definitely recognize when pagination can be used to your benefit, because that's often the easiest and cheapest way to split data up into multiple smaller reads. And that's oftentimes a cheap enough solution to just kind of get you out of like a performance issue. Okay.
Hmm.
Okay, that's the main high level stuff from me. We're a bit over time, but if you have any quick questions, we can definitely go over that as well.
Um, Sorry, I was just jotting it out and I was laughing because it was pretty good feedback. Um, I don't have any particular questions right now, though the pagination one, I think that was right there. I think something I did poorly was I kind of offloaded asking deeper questions earlier because I thought, oh, I can ask them as I model things, but in hindsight, like you said, I ended up going in different directions because of that.
Yes,
So yeah, yeah, I think that was great feedback. Thank you.
you're very welcome.
Yeah.
Okay.